Now we can see the circuit diagram for Swinburne's test. Same circuit diagram we can also use it for speed control of DC shunt motor by varying the flux per pole. We know that speed of the motor is inversely proportional to the field flux, and field flux is directly proportional to the current through the field winding. Therefore, field flux per pole can be varied by varying the external field winding rheostat. In the last experiment, we have seen the connections for the Swinburne's test. Same connections we are using for the speed control of DC shunt motor by varying the flux per pole. Before we start the motor, the field winding rheostat is at a minimum resistance position. Now we can switch on the MCB and we can start the DC shunt motor by using the 3-point starter. Now motor is getting started. Now the supply voltage is 230 volts, armature current is 0.96 amperes, field current is 0.67 amperes. For this field current, the speed of the motor is 1505 rpm. Now we are going to reduce the field current to 0.6 amperes by adjusting the field winding rheostat. At this condition, the armature current is 0.94 amperes, supply voltage is 230 volts. Now we can see the speed of the motor is 1553 rpm. Now again we are going to adjust the field winding rheostat and we can set the field current to 0.55 amperes. Now we can see the now the motor is running at 1585 rpm. Again we are going to adjust the field winding current to 0.5 amperes by adjusting the field winding rheostat. Now we can see the speed of the motor is 1620 rpm. Now we are going to set the field winding current to 0.45 amperes by adjusting the field winding rheostat. Now we can see the speed of the motor is 1665 rpm. Now by adjusting the field winding rheostat, we are going to set the field current to 0.4 amperes. At this field current, the speed of the motor is 1721 rpm. Again we are going to set the field current to 0.35 amperes by adjusting the external field winding rheostat. At this field current, the speed of the motor is 1791 rpm. Now we are going to set the field current to 0.3 amperes by adjusting the field winding rheostat, and we can see the speed of the motor is 1866 rpm. Now the field winding rheostat is at maximum resistance position. We can't increase the resistance, so we can't adjust the field winding after the maximum resistance position. Now we can draw the motor speed versus field current characteristics for a DC shunt motor. Now we can see the observation tabular form for the speed control of DC shunt motor at no load by varying the flux per pole. Now we can see the motor speed versus field current characteristics of a DC shunt motor. On x-axis we have taken field current in amperes, on y-axis we have taken motor speed in rpm. If you observe these characteristics, the motor speed is inversely proportional to the field current.
We can use this circuit diagram for speed control of DC shunt motor by varying the resistance of armature circuit, that is armature controlled resistance. Here by using this voltmeter we can measure the voltage across the motor terminals, and by using the line current ammeter we can measure the current drawn by the motor. By using this voltmeter is connected across the armature terminals A and AA. By using this voltmeter, which is connected across the armature winding terminals AA, we can measure the voltage across armature winding terminals, that is back EMF plus IaRa drop meter. And by using this ammeter, armature winding ammeter, we can measure the current drop through the armature winding. And by using the field winding ammeter, we can measure the current through the field winding. Now we have connected one armature controlled resistance in series with the armature winding. We have connected the circuit diagram as per the given circuit diagram. Now I am going to explain the components in the circuit diagram. Now we can see the armature controlled resistance, that is we have connected one rheostat in series with the armature winding. Now the armature controlled resistance is minimum resistance position. Now we can see the digital voltmeter. This voltmeter is connected across the armature winding terminals A and AA. This voltmeter measures the voltage drop across EA plus IaRa. This 0 to 300 volts range moving coil type voltmeter is connected across the motor terminals plus and minus. We have removed the external field winding rheostat, which we have connected for Swinburne's test as well as speed control of DC shunt motor by varying the flux per pole. Now we can switch on the MCB and we can start the DC shunt motor by using the 3-point starter. Now we can see the motor is running at no load condition. We have not connected load. We can also observe that this armature controlled resistance is at minimum resistance position. Voltage across armature terminals, that is AA, is 231 volts, and current through the armature winding is 0.9 amperes and field winding current is 0.64 amperes. The voltage across the motor winding terminals is that is the supply voltage is 231 volts, and current through the line is sum of the armature winding current plus field winding current, that is 1.6 amperes, and motor speed is at no load condition is 1527 rpm. Now we are going to set the voltage across the armature winding terminals is to 225 volts by adjusting the armature controlled resistance. Now we set the voltage across the armature winding terminals is 225 volts. At this condition, speed of the motor is 1490 rpm. At this condition, supply voltage is 231 volts and armature current is 0.92 amperes and field current is 0.63 amperes. Again we are increasing the armature controlled resistance such that the voltage across the armature winding terminals as 220 volts. At this condition, the current through the armature winding is 0.91 amperes and current through the field winding is 0.63 amperes. At this condition, the motor speed is 1462 rpm. Now by increasing the armature controlled resistance, we can set the voltage across the armature winding terminals as 215 volts. At this condition, the current through the armature winding is 0.89 ampere, 0.90 amperes,
and current through the field winding is 0.61 amperes, and speed of the motor is 1430 rpm.
Now again we are going to increase the armature controller resistance such that we can set the voltage across armature terminals is 210 volts. Now we can see the armature current is 0.89 amperes and current through field winding is 0.61 amperes and motor speed is 1404 rpm. Again, by adjusting the controller resistance, we can set the voltage across armature terminals is at 205 volts. Now we can see the current through the armature winding is 0.87 amperes, field current is 0.61 amperes, and motor speed is at 1376 rpm. 1376 rpm. Again we can increase the controller resistance and we can set the voltage across armature terminals is 200 volts, and now we can see the current through the armature winding is 0.86 amperes, field current is 0.6 amperes, and motor speed is at 1339 rpm. Now the controller resistance is at maximum position, so we can stop now. We can decrease the controller resistance to minimum position. After that we can switch off the DC supply. Now we can see the speed observation tabular form for speed control of DC shunt motor at no load by varying the armature controller resistance. Now we can see the motor speed versus back EMF characteristics. On x-axis we have taken a back EMF, on y-axis we have taken a motor speed in RPM. If we observe these characteristics, motor speed is directly proportional to the back EMF.